Good morning and welcome back. I am currently on my way back to Lynchburg from Atlanta and Houston, so I'm going to make a video here for you so that you can review a little bit and learn maybe something new before the week starts. So today we're going to talk about quadratic functions and models. So why do we use these? Well, we use these whenever we throw something into the air, all right? Usually things go in this kind of a path. Sometimes it's a little bit more shallow. And we kind of want to know what time is that ball or whatever we're throwing in the air going to land. So that's the big idea behind this. So we'll play around with that later on this week. So let's look at the main components of a quadratic graph. Quadratic graphs, remember, make parabolas. So when you have a parabola, you've got different parts of a parabola that we're going to talk about. So let me erase this real quick. All right, so if you could fold a parabola in half, you would have something called the axis of symmetry, meaning this point right here corresponds to that point. They are like mirror images to each other. They're the same distance to the center. All right, just like this point corresponds with this point. All right, they are the same distance to the center. All right, and then we've got one more thing. We've got something called a vertex. It's basically where it turns. Sometimes you'll hear it called a turning point, meaning it's turning. If you were driving in a car in this shape, where are you going to start turning? You're going to start turning right about there. That's the main turning point right there. And that's called your vertex. All right, so let's look at some stuff. If you graph a quadratic, it is always symmetrical. If you know what half of the graph looks like, you can do the other half. So if we know where the vertex is, which is right here, right where it turns, we could draw a line going through the vertex that's going to cut our parabola in half. And that's your axis of symmetry. Now you've got corresponding parts that go with each point. So let's see, you've got, from here, it is 1, 2, 3, 4 places. Same corresponding point is 4 places away. This point here on this parabola is 3 places away, and this one is 3 places away. So you can pretty much do this on your own. Let's go to the next one. Okay, so we're going to label the vertex and the axis of symmetry. So remember, the vertex is the bottom point right here. So if you label it, that is the point 1, -3. And then the axis of symmetry is going to go through the vertex and cut the parabola in half. Now, from here, you can graph the rest of the parabola. So you just basically say, well, if this point is 4 spaces away from the axis, we're going to go 4 more. 1, 2, 3, 4, and draw a dot. And then we're going to do, if this one is 5 spaces away, 1, 2, 3, 4, 5, we're going to go 5 more. 1, 2, 3, 4, 5, and draw a dot. And there you've done it. You've drawn the parabola based on the axis of symmetry. I have my nephew with me and he wants to say hi. Say hi.
Hi.
Okay. All right, let's go on to the next page.
Okay.
Now, do you remember what a translation was? Okay, we would have like the parent graph, y equals x squared, and then we have that formula that you learned where you had to translate it h spaces to the left or right, and then k spaces up or down, and your vertex was h and k. And remember that this number is always the opposite of your vertex number. So let's go and look and see what we can do with that. We're not going to worry about comparing these graphs yet. We'll talk about that later, but you should remember that this is going to go up 3, and this is going to open down, and it's going to be a little bit more narrow, but we'll go back and review that on Tuesday. All right, so when you graph these, there's also something else. You've got a vertex, right? If this were the vertex of this parabola and this were the vertex of that parabola, They have different things going on with them. This one is a maximum. It's a maximum if you think about it because it's at the top of the hill. And this one is a minimum because it is at the bottom of like a valley. All right, let's go and look at something else. All right, so remember, this is the form I just gave you of the vertex form, and that this tells you where the vertex is based on the h and the k. So if you have an equation that has a positive 3 inside the parentheses, your x value of your vertex is going to be the opposite, which is negative 3. And if you have a negative 1 here for your k, your y value is going to stay the same, and it's going to be negative 1. Let's try it with something else. What would be the vertex of this one? This would be the opposite here, and it would be at 2. And then it would be the same for this one. It would be 3. All right. We're not going to graph that. So here's your assignment. Your assignment is going to be to write the vertex form based on the vertex. And I do want you to graph it, and I want you to label the vertex. So I'm going to show you how to do number 1 right now. So this is going to be your assignment. It is going to be due today. And I've attached the PDF of this assignment for you. So I want you to know, due today. I'm going to check them tonight, see how you're doing. So let's do number 1 together. So here's your vertex. It's at 2, 3. Let's go ahead and just graph 2, 3. There we go. Now it doesn't really have any kind of different opening. We're just going to assume it's going to be positive. So we could go and I'm going to go ahead and write the equation out first. Y equals, and we do x minus, now what's your x value of your vertex? Your x value is 2, so we're going to put that there, square it, and then we're going to add 3. Now from here, to graph the rest of it, I would like you to know the standard form of a parabola. But if you don't, you can go into your table and you can make one if you have that on your calculator. So you can either make a table, or you can just know if you go from the vertex, you go over 1 and up 1 in either direction to make your parabola. That means x squared, right? 1 squared is 1 also. And then you go over 2 and up 4 to get to the next point. That basically means 2 squared is equal to 4. So I'm going to do that for the next one. Over 2 and up 4. And then the last one is going to be over 3 and up 9. And I can't quite get there on my graph, so I'm just going to go a little bit like that. All right, and that's what my graph would look like if I knew how to just graph the standard form of a parabola. Now, if you were using your calculator, you could go and find all these points. I would use -1, 0, 1, 2, maybe 3 and 4 to find your points. You really only need to do one side because then you could do the other half using the axis of symmetry. So here's your vertex, and our vertex again is at 2, 3, and our axis of symmetry goes down the middle through the vertex. All right, so if you only have one point here, let's say you found this point at 0. What is this point? 0, 1, 2, 3, 4, 5, 6, 7. You could go find the other one by counting 1, 2 in. So let's go 2 more to get to the next point. So that's going to be what? What is that? That's going to be 4, 7. So that's another point. All right, or you could just use your table for now. All right, so your assignment, again, is to do this. It is due today. I want you to graph them. I want you to label the vertex, and I want you to write the equation in vertex form. And it's due today. You want to check your other, the other link. It gives you this assignment. All right, I will see you tomorrow. Have a great day. Turn your paper in today, and I will see you tomorrow.